The first thing that we need to talk about is the discriminant. Now, this is on your worksheet that you're doing. I mean, not your worksheet, but your stuff you must know cold for Monday that you already have memorized, I'm sure.
What is that other thing next to the A?
It's b squared minus 4ac.
Oh, see. There we go.
This will tell you if something is prime or not. Because some of those polynomials ask you if something's prime. If b squared minus 4ac is something like 4, 9, 16, 25, 36, 49, what do all those numbers have in common?
You can't.
I can do what with them?
You can square them. So.
I could square them, but I can take the square root of all of these.
That's what I'm going to say.
Yeah. So if I can take the square root of whatever the discriminant is, then it's not prime. Then I can factor it. But the discriminant is the b squared minus 4ac. Like I have to figure it out. But so if you can't figure out something to factor, if you want to check to see if it's prime or not. If it's not a perfect square, then it's prime. If it's negative, it's prime. If it's not a perfect square, it's prime. All right, that's how you check to see if something's prime or not. Didn't know where the a, the b, and the c come from in the discriminant. It comes from this standard form of polynomial. So in this problem, a is equal to 6, b is equal to 41, c is equal to 70. But one thing we also need to be aware of and sure of is if this was a minus 70, then that would make c negative 70. If this was a minus 41x, that would make b negative 41. So whatever sign's in front goes with the number when I'm identifying a, b, and c. Alright. So the first thing we need to do is multiply a times c together. In the box below, we want to put b in that box, which b is 41.
No, we didn't.
No. Okay. So here, what I need to know is I need to break down 420 into two numbers that
4 and 20.
multiply to give me 420, and add to give me 41.
What the heck?
I thought you said this.
See, the other way is so much easier.
Yeah.
Now that I have my numbers, I'm going to make two fractions, and we'll do more than this example. All right. So because you're going to have two parentheses in your answer, right? Everybody understands that much. This is how I know what goes in parentheses is I'm going to make two fractions, and each fraction is going to represent a parentheses. All right. On top of each fraction, I'm going to put whatever's in front of whatever a is at the very beginning. So a is 6, so I'm going to put 6 on top of both of those fractions. Then on the bottom of the fractions, I'm going to put whatever my two numbers are over here. And then if one of these were negative, then the negative would come over there with me. Now all I need to do is I want to simplify the fractions. So 6 and 20, 2 will go into 6 3 times. 2 will go into 20 10 times. Then 3 will go into 6 twice. 3 will go into 21 7 times. So the top number. So we know that our parentheses are going to have an x in them. Right. The top number of the fraction tells you what goes in front of x. So 3 goes in front of x. All right, so that one should be 2. And 2 goes in front of this x. Then the bottom number tells you the sign and what the other number should be. Since that's a positive 10, I've got 3x plus 10. And then since that's positive 7, I got 2x plus 7.
No, seriously, like asking.
On this problem, A is 10, C is 6, so 60 would go in that spot, and 23 would go in the middle. I mean, on the bottom left. 23 is in the middle, so it's B. So now I need two numbers that multiply to give me 60 and add to give me 23. And that's what? 20 times 3 is...
That's a good one.
Oh, that's a good one.
Yeah,
That's good.
it's the only one that works. I didn't record any of that. So does anybody have any questions? Where you've got some negative signs in there. So if I multiply 4 times negative 12, in this spot I'm going to have negative 48. And then on the bottom I'm going to have negative 22. So I need two numbers that multiply to give me 48, negative 48, and add to give me negative 22. So what's that going to be? Well, 1 times 48 is 48. 2 times 24 is 48. 2 and 24 look like it's going to work.
Yeah, because you got to subtract them, right?
Well, so if right now they're both positive, so that's not going to work because it's going to give me a positive
You
48.
got minus or 24.
So-
minus in front of them.
Minus in front of the 24, because when I add negative 24 and positive 2, I'm going to get a negative 22. Alright, now our only step is to make the fractions again. 4x over negative 24. And then 4. Sometimes I put the x up there, sometimes I don't. You don't have to put the x. You just got to simplify the fractions. So 4 goes in there one time, 4 goes in there 6. 2 will go into there twice, 2 will go in there once. So my parentheses are x minus 6 and 2x plus 1. Now I do want to point this out. Do you know how you can go back and check yourself if you factor?
Yeah.
You can pull it back out.
See that?
If I pull this first step out, x times 2x is what? 2x squared. Is that what my problem is up here?
No.
No. Because this brings out an interesting point that I make this mistake all the time when I'm doing this. This is still right. This down here at the bottom is right. The only thing is, up here at the top, there's a number that we could pull out of all these. We could pull out a 2. So when I factor, if something's off on the front number, like when I factor this way, if something's off at the front, then I have to go back and see if I can pull out a number at the top. I can divide each of these by 2. So really what we factored was 2 times 2x squared minus 11x minus 6. So we factored this, and we have a 2 on the outside, and that's what it would give us there. Here I can't pull out a difference. I can't really do a difference of squares right now, but what could I pull out of both of these terms? I can factor a p out of both of those. I could factor out a 2, but I don't want to because it'll mess up the difference of squares. I can't factor a 2 out of 81. So that works out. On the one that's like this on your paper, you could factor a 2 out, but don't because it messes up the perfect square.
Okay, so if we're doing difference of squares, do not take anything out of the numbers.
Well, just check to see if it is a difference of squares. It may not be a difference of squares, and that's as most you could do.
2 squares in the minus in the middle is a difference of squares.
This is a difference of squares. This one is a difference of squares because I can take the square root of m squared and 16. And I can take the square root of 81x squared. And there's a minus sign in the middle. That's what difference means. So it's a difference of squares. So this is just like the formula on your sheet for stuff you must know cold. So the square root of 16 is what? 4. Square root of m squared is m. Your parentheses are always going to have different signs in the difference of squares. Alright, then 4m is going to go in front of both parentheses. Should be an m.
M or N?
M, sorry. And then 81, the square root of 81 is 9. The square root of x squared is x. So 9x goes for both of these parentheses.